Now I'm going to go over how to test resistance. Now this symbol right here is the ohm symbol, and that's the symbol for resistance. Whenever you turn over here, you're going to see OL, which is over limit, which means infinite resistance. So when you're in this mode, what the meter is sending a small amperage in the positive, and it's seeking a return on the negative. So once you touch, it's going to show you the resistance. So as you can see right here, this wire has a resistance of 0.1 or 0.2. If you have the option, you could zero this out, but if you can't zero out this meter, you can take this as a reference. So say you have 10.2, then you know your resistance is 10 ohms and not 10.2. Right here is a starting solenoid for a Ford truck. Now these two big terminals is the secondary, and the primary, where the copper winding is right here, and the ground. This is mounted on the chassis. So I would test here and here with my meter set at ohms. And since this is brand new, I have a reference to test on the one on the truck. So this one has a coil reading of 3.2, so it's 3 ohms. So if I go to the truck, I can test that one to see if it's close to the 3 ohms. If it's relatively low or high, then I know it needs some replacement. Or the connection is poor, or the wire is building up resistance. So that's the coil. For a relay, you could test the coil on it too. Here's a 24-volt relay. You could do the same thing. You could test the resistance of the relay. So here's the two terminals. 85 and 86 is the standard number to test the coil. Put it together, you have 323 ohms. And because this is a 24-volt relay. Same thing for this, is also a 24-volt. Not sure if you can see the diagram, but this is actually a diode relay. So I'll show you how to test this later on. This one has no diode, so you can test these two. Normally it's the two oddball terminals that are the coil. You can test this. You have 609 kilo ohms, quite a lot. Now on to the diode mode. Now when you come to the diode mode, this is actually a function that you could use two ways, because it also measures ohms over here. So if you touch it, one thing that's good about this is if it's quiet enough, you can actually hear an audible tone whenever this is touched. So this tells you that there's continuity crossing. If the resistance is too high, it won't cause an audible. It'll still do the ohm reading. See right here? You have 300 ohms, so it's doing the reading, but it doesn't have the audible, because the audible is supposed to show you that there is continuity. Now here's an example with my other meter. When you're in the resistance option, you can also have audible and diode testing. Now you hear the audible, at the same time you see 3.5 ohms, so it's doing two things at once. So this is when you don't have time to look at your meter all the time, but you want to make sure that there's continuity. So you put it in the audible position so you can hear the audible each time. Now right here is what they call a diode. Now if you see this gray strip, you know on the symbol side it's pointing where the strip is farthest to. So you know the power goes this way, but it doesn't go this way. It prevents surges. You want to use diodes if you want to protect sensitive electronics. So over here, in reverse, it won't work. But if you turn it around, you have 500 ohms. So this is actually a resistor diode. And here's a better example of the diode. So over here is a bunch of diodes. So what it really does is it connects this input to this output. And this is the diode that's keeping it. Right now I'm in the resistance mode and I set it onto the diode. You can see there's a diode symbol right here. I apologize for the glare. So I know that all the diodes are pointing upwards. So my positive, my input, has to be on the bottom, and my negative is the output on the top. As you can see, it's reading that it takes about half a volt for it to go through this diode. Now if I were to reverse this, it won't go through. That means the diode is working at blocking the current going past. So just keep in mind the positive has to go through the diode, not the other way around. So the positive has to go the direction of where the arrow is in the schematic. Again, half a volt, you reverse it, 0. So you could go down the line right here to test all the diodes. All the diodes. Now if you come here to here, you'll see that there's 537. But if you come over here, you won't see it because the diode is working. It's doing its job. It prevents any back surges back to the sensitive electronics. Now if you want to check the wiring if the continuity is good, say for instance, now I just pulled this wire out of my other meter and I want to check if there's any resistance or if there's good continuity in this wire. Because if you pull on this wire or tug on it, if you roll it over with something, you could break the internals without seeing it. So what I'm going to do is I'm going to use the diode test to see. I want to hear a really good audible. Now if I touch, now I have 0 ohms, that means this wire is good. If I see OL while I'm touching this wire could be bad. So if you're dealing with a really long wire, this is a good test. There are times when you have to test all the wires and you have no time to look into the meter. So it's good to just have this audible so you can just go down the line, and if you hear the audible, you can move on to the next one. Now a really great way to test for fuses is you can go to this diode mode right here, verify that the audible works, and in the back of the fuse you see these 2 terminals. You can just go down the line and check if each and every one of them is working. You want to see 0 ohms because if you see a high reading, it could be somewhere in the circuit that is closing. But if you go down the line right here, you can test if a fuse is good or not. Now if you don't hear the audible, that's the fuse that's blown. Another great way to use your resistance test over here in the ohms is you could test a lot of things that's around us. For instance, this is a typical headlight. This is a dual beam. If you look closely inside, there's 2 filaments. One filament is for the low beam and one filament is for the high beam. Now you can sometimes see if it's blown or not because you can see the filaments disconnected. But with the resistance test, there should be 3 terminals. One's the ground terminal and the other 2 goes to the other two filaments. I'm going to just set it into the audible, which is the same, just to see that there's continuity. 0.6 ohms, 0.3 ohms. Now here is an 1156 light bulb. This is commonly used for turn signals and reverse lights. So the center part is where the positive goes to, and the body of this light bulb is the ground. Now if I touch this, I'm supposed to see a ohm reading. I have 18 ohms in this light bulb. Red to the center, ground to the body. I have resistance. I have about 30-ish ohms. Now you have to have a really good connection. Now I have about 10 ohms. That's the lowest reading I have. This is a dual filament. This is commonly used for brake lights and tail lights. So one of the filament is lower beam, that's for your tail light, and when you step on the brake, both of these light up, causing that brighter red light in the back. So the body is the ground, and these two terminals right here, one is for brakes and one is for tail light. So I'm going to test. This one has 4.1 ohms. The other one should have a double or half the amount. This is 2.5. So the 2.5 should be the brake light. Now if you can see, one has a coarser coil. So you're going to notice a resistance difference because one will be brighter than the other. Now with my hand on the body for grounding, one of the terminal is 4.2 ohms and the other one is 2.5, and because of that difference in ohms, one is brighter than the other. Now this right here is a pressure switch. Now whenever there's pressure, this ball bearing goes down and make contact between these two. Now instead of replacing parts, you can just hold both terminals and you press it with your bare hands to see if the switch is working. I'm letting go, open, pressing down, you see continuity going through. So this switch actually works. You can use the audible, pressing down, letting go, pressing down. Same thing for these toggle switches. All it is two terminals. So if you were to hold on to here, so this is a normally open switch. When you flick it on, I'm supposed to hear audible. Which means it's making continuity. So it's always nice to know how to test the parts before you replace it. It could save you a lot of money. And for this starter solenoid, I know that there's a coil winding on the primary and the secondary should be open at all times until this is energized. When the primary is energized, then the secondary closes. So right now I'm expecting this to be closed, so right now I'm expecting this to be open and no continuity going through as expected. But I'm expecting resistance on the primary circuit. There's about 3 ohms on this coil. Right here's the starter solenoid. For the resistance mode, you can actually test how good your body ground is. So make sure whatever you're testing, the bolt is clean with no paint on top. As you can see, I'm touching a bolt that has paint on it. So it's going to have a really high reading, if any reading at all. Now if you were to touch the engine block, I'm touching the aluminum part of the engine block, you're going to have a reading. So you have 0.3 ohms, which is pretty good for a body ground. So now you know that the engine is grounded to the battery. Now you can do these tests on ground straps. Usually you see it in the fender. Now if you have a relatively high resistance on the ground strap, it's either really old and brittle or it's a poor connection, so you might want to check there. It could restore some performance in your vehicle.